Hi, this is Dr. Eddie Morgan from Clovis East High School, ready to help you with your homework tonight. Tonight we're going to be looking at Math 1 homework, worksheet 3.6. Remember, each question on your homework is mirrored by a question on this homework help. So let's get started. Our first question asks, which of the equations below have graphs that are parallel to one another, and then which are perpendicular? This is a key concept. Remember that if the slopes are the same, that implies that they're parallel. If slopes are what we call opposite reciprocals, that implies they're perpendicular. Opposite reciprocals means if I have a slope, for example, of 2/3, that's positive. The opposite would be negative, and then the reciprocal would be 3/2. Those are opposite reciprocals. If you have a slope of, let's say, -3, you could consider the perpendicular will be positive. The reciprocal of 3 is 1/3. Those would be samples of opposite reciprocals. So what we need to do in this problem is simply identify the slope. Notice in the first one, my slope is considered in the slope-intercept, this would be +0. My slope is right here. So the slope of this one is -1/7. Here again, there's no y-intercept. My slope is simply 7. And here, my slope again is 7. So notice when I'm looking for parallel that have the same slope, notice I have here and here. So the parallel lines are y equals 7x and y equals 7x minus 3. So that's the answer to the first part of the question. And then notice here, if I look at that one there, notice that the opposite of 7 can be written as 7/1, so the opposite reciprocal will be -1/7. So that means this one is perpendicular to that one and that one. So perpendicular lines would be, let's just call these A, B, and C. So perpendicular lines would be A and B, or A and C. Those would be the perpendicular lines. There's our opposite reciprocals. Problem 2 asks us to write an equation of a line that passes through the point 4 minus 2 and is parallel to this equation here. Now, the answer here, and they want it in the slope-intercept form. Well, our strategy is going to be, we know that if it's parallel, it's going to have the same slope. So to write a line parallel, the slope of this line is -5. And they wanted to go through the point 4 minus 2. So I have everything I need. I have a point and a slope. So if I use the point slope form, remember that one, that's y minus the y in the first value equal the slope times x minus the x in the x value. There's my slope. Here's my x1, y1. So let's just plug them in. So I have y minus -2 equals -5 times x minus 4. Now they want it in the slope-intercept form, so we'll need to do a little adjustment here. First we'll distribute, and here y minus a -2 is y plus 2 equals -5x, minus a minus is going to be +20. And now we'll undo the +2 on this side by subtracting 2. And our final answer will be y equals -5x +18. And that's the line that is parallel to this line. Notice they both have a minus 5, but it goes through a different point, 18 instead of 1, and it goes through the point 4, negative 2. Problem 3 is very similar to problem 2. We're asked to write an equation of a line that passes through a point, this time 3 minus 4, but this time they want it to be perpendicular to this line. Now remember, the perpendicular, if the slope of this line is 1, what's the perpendicular slope? Well, remember the perpendicular slope, and I'm going to put a little note down here, this is my perpendicular, is the opposite reciprocal. So what's the opposite of 1? Well, the opposite of 1 is minus 1. The reciprocal would still be 1 over 1, so it's just simply minus 1. Okay? So now, once again, let's go back to the point-slope form. And we have, remember, y minus the point y1. And again, here's my point. So this is my x1 and my y1, which simply means a point. And back to the point-slope form is equal to m times x minus x1. So let's plug in here. Y minus minus 4 equals the slope now is negative 1 times x minus 3. So to get it now in the slope-intercept form, first thing we'll do on this side, we'll simplify by distributing. And over here, we recognize that subtracting a negative is the same as adding the opposite, which means adding plus 4. So we have y plus 4 equals minus x plus 3. Now to complete our transformation, we'll undo the plus 4 by subtracting 4. And that goes to 0. And we're left with y equals minus x plus 3 minus 4 is minus 1. And that's our answer. Problem 4 asks us to tell whether two numbers in each pair are opposite reciprocals. Remember what opposite reciprocals are. And just take each word by itself. If I have a number like a over b, the opposite, this is plus a over b, the opposite would mean it's negative, and the reciprocal would mean it's turned over. So again, if it is a fraction like 3/4, then the opposite reciprocal would be negative 4/3. If you start with a whole number like 5, consider that to be a fraction, 5 over 1, and then the opposite reciprocal is minus 1 over 5. So one way to do this is simply to look at it and say, okay, minus 3, what's the opposite? The opposite is going to be positive, and then the reciprocal of 1/3 is going to be, of 3 is 1/3. So yes, that is an opposite reciprocal. When I look at the second pair, let's start with 1/5. The opposite of that would be minus, and then the reciprocal would be minus 5 over 1. But notice here, that's positive 1. So this is no. So what they've given us here is the reciprocal, but not the opposite reciprocal. And in our last one, we start with 4. If I want to, the opposite of 4 is minus, and then the reciprocal will be 1 over 4. But I have minus 4. Here, what they've given us is the opposite, but not the reciprocal. One other thing you can always do is a check. Notice if I take any of these two down here, if I take a over b and multiply it by b over a, notice that I get minus ab over ab. I always get minus 1. That's a way to check. Notice, for example, here, minus 3 times 1/3, make that a fraction. Minus 3, I get minus 3 over 3, which is minus 1, so I know I have an opposite reciprocal. Here, however, if I take 1 over 5 times 5, notice I get 5 over 5, which is 1, not minus 1. And here, obviously, if I take 4 times minus 4, I get minus 16, nowhere close to negative 1. Okay. Problem 5 is an open-ended question, which means that an infinite number of possible answers. All they're asking us is to write an equations of two parallel lines. So the key thing about parallel lines is the slopes have to be the same. That's the only thing. So let's pick a slope. I'm going to let slope equal 2. Now all I have to do is write two equations with a slope of 2. One of them could be y equals 2x. Another one could be y equals 2x plus 1. I could write a third one, y equals 2x plus 2. I could go the other direction, y equals 2x minus 1, y equals 2x minus 1,000. You see, all that's important is that my slope is the same and all those lines would be parallel to each other. Problem 6 asks us to compare and contrast. How is determining if two non-vertical lines are parallel similar to determining if they're perpendicular, and how are they different? Okay. Well, first of all, how are they similar? Well, they're similar. The way they're similar is because you have to compare the slopes to each other. In other words, if I want to see if two lines are parallel or perpendicular, I have to find out what the slopes are and then look at them. All right. How are they different? Well, they're different because if the slopes are parallel, if the slopes are the same, then that implies that the lines are parallel. However, if the slopes are opposite reciprocals, this implies that they're perpendicular. So in other words, when you're trying to find this information, the one thing you're always going to do the same is find the slope and compare them. That's the thing that's the same. That's what's comparable. But then because they're different, if the slopes are the same, they're parallel. If they're opposite reciprocals, then they're perpendicular. Problem 7 is just going to ask us to apply all that we've learned about parallel and perpendicular lines to these 6 lines and find out which are parallel and which are perpendicular. So all we have to start is to figure out what's the slope. So line A, slope is 4. Line B, notice line D, I mean here, this is y equals 0x plus 3, so the slope is 0. Here I have a horizontal line, so the slope here is undefined. Notice there is no y here, so this is undefined. And here my slope is right here, minus 3. And over here the slope is 1/3. And finally here we might have to shift it around a little bit. Let's move the 8x so we get minus 2y equals minus 8x plus 5. Divide by minus 2, everything. And we get y equals 4x minus 5/2. So the slope is 4. Okay. So let's look for parallel lines. Where is the slope the same? Well, I have a 4 and I have a 4. So parallel lines would be line A and F. All right. Any others? 0, undefined, minus 3, and 1/3. Okay. Let's talk about perpendicular lines then. Looking for opposite reciprocals. If I were looking for the opposite reciprocal of 4, I'd be looking for minus 1/4, and I don't see it. So there's nothing parallel to A and F. Let's look here at an easy one. What's the opposite of negative 3? The opposite reciprocal would be positive 1/3. And if you notice there, We have that right here. So what we have for our perpendicular lines here is line E and C. But let's look at our other two lines. These are interesting here. 0 and undefined. Notice that if the slope of one line is 0, the opposite would be negative, but the opposite is 0. Negative doesn't have a positive 0, and what would be the reciprocal would be some number. If this is 0 over 1, would be minus 1 over 0. But notice 1 over 0 is undefined. So we have to say that these two lines are perpendicular. So D and B are. Because what you have here is in D you have a horizontal line, and in B you have a vertical line. And so those are perpendicular. So there's our two answers, parallel and perpendicular. Our last three problems ask us to determine whether each statement is always, sometimes, or never true, and then explained. The first one is the trickiest one. It says a horizontal line is parallel to the x-axis. So we're thinking here, here's my x-axis, and if I have a horizontal line, I'm looking and going, oh yeah. And I'm tempted to say always. But the answer, surprisingly, is only sometimes. Okay? And the reason it's sometimes is all the lines are going to be parallel. That's true. But there's one line, if my line actually is the x-axis, then they're not considered parallel to the same line. So in other words, this is true all the time except for one line. All right? A horizontal line has the same slope as the x-axis and is parallel unless it is the x-axis. And then it's the same line. Okay? So that's the point of that. In other words, almost every horizontal line is parallel to the x-axis unless it is the line y equals 0, which is the line itself. Number 9, two lines with positive slopes are parallel. Well, this is easy to see that it's not true. If I draw a thing here, and I'm going to draw one that's parallel, positive, excuse me. Here's a positive one. But notice, here's a positive one. Here's a positive one. And notice, just being positive doesn't mean that they are the same. Okay. In other words, being positive doesn't mean the slopes are equal. If I have slope 1 is equal to 2 and slope 2 equals 3, they're both positive, but they're not the same, so they're not parallel. All right. Our last question says two lines with the same slope and different y-intercepts are perpendicular. Obviously, if they have the same slope, that means they're parallel. Okay? Not perpendicular. To be perpendicular, they would have to have opposite reciprocals. All right, so I hope you did a good job on your homework tonight. Have a good day in school tomorrow.